NASA didn't call a press conference. There was no breaking news banner, no dramatic headline. They just updated the numbers. And buried inside those updated values was a problem that refuses to go away. Because 3I Atlas is now behaving even less like anything we've ever cataloged before.
As 3I Atlas nears Earth, sunlight is breaking down its icy surface, releasing cyanogen gas. That's what gives it that eerie green glow. Telescopes across the globe are locked on, tracking every change, every flicker. This is no ordinary comet. It comes from another star system, flung into our neighborhood by some ancient stellar collision. 3I Atlas will make its closest approach to Earth on 19th of December, passing within about 269 million km.
At first glance, the update looked routine, minor revisions, slight changes to trajectory estimates, normal science housekeeping. But when independent astronomers and data analysts compared the new figures to the old ones, something uncomfortable became clear. The object wasn't settling into a clearer explanation. It was drifting further away from every known model. From the moment 3I Atlas was first flagged, scientists tried to treat it like a standard interstellar visitor. We've seen those before, objects that pass through the solar system from beyond, following predictable hyperbolic paths, showing expected behavior as they interact with solar radiation. But 3I Atlas has never fully cooperated with that assumption. And now, after NASA's quiet recalculation, it's cooperating even less. Let's start with the orbit. Interstellar objects typically arrive fast, pass through once, and leave forever. Their paths are steep, their velocities extreme, and their trajectories fairly easy to backtrace to outside the solar system. With 3I Atlas, the original numbers already raised eyebrows. Its incoming velocity was high, but not as high as expected for something unbound to our star. NASA's update made that discrepancy sharper. The revised velocity suggests the object is losing and gaining speed in ways that don't align cleanly with gravitational influence alone. That shouldn't happen. At least, not without visible forces acting on it, outgassing, fragmentation, or some measurable interaction with solar wind. But telescopes aren't seeing those signatures. No expanding debris cloud, no classic cometary tail, no consistent jet activity that would explain the momentum changes. Instead, 3I Atlas appears restrained, controlled, as if whatever forces are acting on it are either extremely subtle or entirely unfamiliar. Then there's the brightness problem. NASA adjusted the object's absolute magnitude slightly downward, meaning 3I Atlas is reflecting less light than previously estimated. That might sound minor, but it has big implications. If it's dimmer than expected, then either it's smaller than we thought, or its surface is absorbing light far more efficiently than known cometary or asteroidal materials.
A green ghost from the stars is racing towards Earth.
It's not a myth, not a rumor anymore. A real interstellar comet glowing brighter every night, and scientists are watching because 3I Atlas is about to make its closest pass yet.
A visitor from beyond our solar system is now blazing a green trail across the night sky. New images show it growing brighter, its core swelling, its tail stretching behind like a cosmic ribbon.
This next story explains how this is a Christmas gift for astronomers around the world.
Deep in the black, something is moving fast. Interstellar Comet 3I Atlas.
Both options are uncomfortable. If it's smaller, its mass estimates fall apart. Yet the gravitational effects inferred from its motion don't scale down accordingly. If it's highly absorptive, then we're dealing with a surface composition unlike anything commonly found drifting between stars. And the color data didn't help. The updated spectral readings place 3I Atlas in a strange middle zone. It doesn't match the icy signatures of classic comets, but it also doesn't line up with metallic or rocky asteroids. It's not red enough, not neutral enough, not reflective enough, and it's off. Astronomers have tried to force it into categories. Some argue it's an extinct comet with an unusually dark crust. Others suggest it's a fragment from a protoplanetary disk, weathered by millions of years in interstellar space. But here's the issue. Interstellar exposure usually makes objects more predictable, not less. Radiation, cosmic dust impacts, and thermal cycling tend to homogenize surfaces over time. They erase complexity. They don't produce finely tuned anomalies that only show up when you refine the data. Yet every refinement of 3I Atlas makes the object harder to simplify. NASA's updated positional data also revealed something subtle but unsettling. When plotted over time, the deviations from predicted positions don't scatter randomly. They cluster. They show directionality. That suggests influence, not necessarily intelligence, but intention-like consistency. A push that repeats under similar conditions. A response to solar proximity that doesn't flare wildly, but adjusts just enough to matter. This is where comparisons to past anomalies come back into the conversation. Scientists eventually lean toward non-gravitational acceleration caused by hydrogen outgassing, an invisible propulsion mechanism. It was controversial, but at least it fit within speculative physics. With 2I/Borisov, the comet behaved more normally, reinforcing the idea that Oumuamua was simply rare. 3I Atlas now refuses to follow either script. Its acceleration profile doesn't cleanly match gas release models. Its thermal response curve is flatter than expected. Its rotation, based on light curve analysis, appears unusually stable, lacking the chaotic tumbling seen in many small bodies. Stable rotation requires internal cohesion. That means either it's a solid, well-bound object or something structured. NASA hasn't said that last part. Officially, the updates are framed as improved precision, better tracking, more accurate modeling. But scientists watching from the outside know how this works. When models improve but confidence drops, that's a signal. It means the math is working, and the assumptions aren't. There's also the silence factor. Normally, objects this interesting spark papers, preprints, conference talks. Instead, updates about 3I Atlas have been quiet, technical, almost buried. No big public outreach push, no dramatic explanations. That doesn't mean a cover-up. It means uncertainty, and scientific institutions hate uncertainty without a containment narrative. The updated numbers have one final twist that's easy to miss if you're not looking closely. The object's future trajectory, after it exits the inner solar system, has a wider uncertainty cone than before. That's backwards. More data should narrow predictions, not widen them. Unless the system is responding to variables we don't fully understand. In plain terms, we're less sure where 3I Atlas is going now than we were before. That shouldn't happen. So where does that leave us? Not with aliens, not with declarations, not with answers. It leaves us with an object that keeps slipping through our definitions, one that becomes more anomalous the harder we look, one that doesn't loudly break physics, but quietly bends expectations just enough to matter. NASA updated the numbers, and instead of closing the case on 3I Atlas, they made one thing clear. Whatever this object is, it's not done surprising us.